Today we're going to talk about a type of factoring called factoring by grouping. Before we actually get there, we're going to talk a little bit about multiplication, right? Because if you can really think about what multiplication means, it's going to make the factoring really easy. Right, so first of all, I want you to think about what does this mean when I write 3 times 4? And there are a lot of different ways to represent this, but one way of thinking about that is thinking 3 times 4, that means there are 3 groups of 4 objects, or 4 whatever you're dealing with, right? And I can draw a little picture of that. So 3 groups of 4, right? Here's the first group of 4, here's the second group of 4, and here's the third group of 4, right? So one group of 4, a second group of 4, and a third group of 4, right? Which adds up to be 12 total little dots there. Okay? So 3 groups of 4 could be represented like that. Right? So this is going to be useful. So get used to this idea, right? So if I had 5 times 6, same thing. We can think of that as 5 groups of 6, right? Or if I had 7x, right? We could think of that as 7 groups of whatever number x is, right? Or 7 groups of x. All right, let's apply that idea to these problems. Okay, so think about this. 3 times 4 plus 2 times 4. You could just multiply this out and add that up, right? But there's another way to think about this, right? And again, this is going to be useful for later. Right? We can think of 3 times 4 as 3 groups of 4. And then over here, 2 times 4, we can think of this as 2 groups of 4. So think about that. If I have 3 groups of 4 plus 2 groups of 4, doesn't that mean that I have 3 plus 2 groups of 4? Or you could say 5 groups of 4. Right, let me say that again. 3 groups of 4 plus 2 groups of 4. So that's a total of 5 groups of 4. Or I could say 3 plus 2 groups of 4. Let's look at another one. All right, 7 times 15 plus 3 times 15. Again, you could multiply these out, but that is might be kind of annoying, and then add it up. But it's going to be so much easier to think about it this way, right? 7 groups of 15 plus 3 groups of 15. So doesn't that mean that I have 7 plus 3 groups of 15, right? Or in other words, 10 groups of 15, right? And you could just multiply that out. 10 times 15 is 150. Okay, I'm not going to actually multiply these out because I'm going to leave these as multiplication problems, right? Which will be important for the factoring we do later. All right, let's look at some other ones. Let's do some that have variables. All right, so let's say I have this, 5x plus 7x. Okay, and you probably know the answer to that already, but I want you to think about it in this new way. This is 5 groups of x plus 7 groups of x. So we could say that that is 5 plus 7 groups of x, right? Which of course is 12 groups of x, right? But I'm going to leave it like this, again, for the purpose of our factoring that we're going to do later. All right, let's look at another one. If I had 9 times x minus 2 plus 3 times x minus 2. Of course, we could distribute and add this all up, but another way to think about this is 9 groups of x minus 2 plus 3 groups of x minus 2. So that's the same thing as saying 9 plus 3 groups of x minus 2. Or in other words, 12 groups of x minus 2. Let me do one more. If I had x times x minus 3 plus 5 times x minus 3, what does this mean? Well, it means I have x groups of x minus 3 plus 5 more groups of x minus 3. X groups of x minus 3 plus 5 more groups of x minus 3. So that could be written as x minus 5 groups of x. I'm sorry, x plus 5 groups of x minus 3. Okay? All right, I would like you to factor these. All right? So I've got x times x squared plus 11 plus 5 times x squared plus 11. How could I write that in factored form? Same thing with number 8. So please pause and do that. Welcome back. I think of this as x times x squared plus 11, or x groups of x squared plus 11, plus 5 more groups of x squared plus 11. So that's the same thing as x plus 5 groups of x squared plus 11. For number 8, we can think of this as x squared groups of x plus 7 minus 3 groups of x plus 7. So that would have to be x squared minus 3 groups of x plus 7. All right, let's take a look at these two examples. All right, and you'll now see why we call this factor by grouping. Because what we're going to do is we're going to break this up into two different pieces. We're going to factor the front group separately from the back group. Right, so take a look at this front group. Ignore the back for a second. If we were taking a look at this, x to the 5th minus 5x cubed, if I were to factor this, what could I factor out? Right, well, I can factor out a GCF, or greatest common factor, of x cubed, which would leave me with x squared minus 5. How about back here? Right, we have this part, but then we need to add that to whatever we get from this part. Let's think about this back part, 6x squared minus 30. Can't I pull out a greatest common factor again? I could factor out 6 times, factor out a 6, and then I'm left with x squared minus 5. All right, well, that's interesting because take a look. In this case, we have an x squared minus 5 here, and we have an x squared minus 5 here. Okay, and I just want to mention, this is not going to happen every single time, but in this case, it works out. So what do I have now? I have x cubed groups of x squared minus 5, plus 6 more groups of x squared minus 5. Therefore, I can factor this as x cubed plus 6 groups of x squared minus 5. And there we have it. This is in factored form, right? We've taken our original expression and we've turned it into multiplication. We've expressed it as multiplication. Let me do another example. All right, so let's again break this up into two different pieces, the front and the back. All right, let's factor the greatest common factor out of the front. So here I could pull out 2x squared. Right, and then I have, what do I have left? I've got x plus 6. Right, in the back, I can pull out a negative 5. So minus 5 times the quantity x plus 6. And let's double check that, make sure we did that right. Negative 5 times x is negative 5x. Negative 5 times 6, negative 30. Good. All right, so again, notice that this x plus 6 matches with this x plus 6. Right? Again, I want to emphasize that this method only works if these things match. Right? And those won't necessarily always match. If they don't match, we know that either we made a mistake or this problem can't be done this way. All right, so the last part's easy here, right? So we've got 2x squared groups of x plus 6 minus 5 groups of x plus 6. So that means we have now 2x squared minus 5 groups of x plus 6. All right, now it's time for you to do these two on your own. So please pause and try these on your own. Let's see if you were successful. I'm going to do these in two pieces. Let's factor the front. I can pull out 3x squared. That would leave me with x plus 5. And in the back, I can factor out a negative 2, leaving me with x plus 5. Right? These match, okay, which makes this very simple, right? I've got 3x squared groups of x plus 5 minus 2 groups of x plus 5. Therefore, I have 3x squared minus 2 groups of x plus 5. Oops, forgot my parentheses. Okay, and then on 12, let's factor the front and the back separately. In the front, I can pull out x cubed. That's going to give me 4x squared minus 7. Back here, I can pull out just a positive 2, right? So plus 2 times 4x squared minus 7. All right? Notice again these match, right? Again, it's not possible to do this method if these don't match. Okay, so now I have x cubed groups of 4x squared minus 7 plus 2 groups of 4x squared minus 7. Therefore, we could say this is the same thing as x cubed plus 2 groups of 4x squared minus 7. All right, the last two. Okay, I'm going to do 13, and I would like you to do 14. All right, these last two have multiple pieces, multiple steps. All right, so take a look at 13 and think about what they all have in common. Right? Because before I use my factoring by grouping method, I want to check to see if there's anything else we can do. And in this case, if you notice the 2, 4, 24, 48, those are all divisible by 4. They all have a common factor of 2. I'm sorry, I might have said 4. Let me say it again. 2, negative 4, 24, 48, they all have a common factor of 2. They're all divisible by 2. Also notice that we have x to the fourth, x cubed, x squared, and an x. So they all have a common factor of 2x. So I'm going to factor, in the very beginning, pull out a greatest common factor of 2x. That will leave me with x cubed minus 4x squared, nope, messed up, minus 2x squared plus 12x minus 24. Okay, see, I can make mistakes too, so always double check. 2x times x cubed is 2x to the fourth, 2x times negative 2x squared, negative 4x cubed, 2x times 12x, 24x squared, 2x times negative 24, minus 40x. Okay, we're good. All right, so that's the first thing that we want to do, is factor out this 2x. Right, and then we're going to continue with this just like we did before, right? Let's leave this 2x out in front, and then work on the inside here. So we can factor the front and the back separately. In the front, I can pull out x squared, right, times the quantity x minus 2. Right? In the back, it's going to be plus, and I can pull out a 12 times the quantity x minus 2. Right? So let's leave this 2x out in front, and then what do we have inside here? We have x squared groups of x minus 2 plus 12 groups of x minus 2. So that means that I have x squared plus 12 groups of x minus 2. All right? So it's just a little bit tricky because we have this 2x out in front. Right? But notice this 2x just stays out in front. That's this factor that stays constant. Right? But then, and then the rest we do like we did before. Okay? So this right here is our answer. All right, I would like you to do this last one. Okay, and I want you to kind of think about it. There's more than just one type of factoring that you're going to have to do here. So please pause and try to think about this and do this one. All right, let's see if you got the right answer. All right, this one, let's first check. Can we factor out a greatest common factor? Do these four pieces, four terms, do they have a common factor? The answer is no. So we can't factor out a greatest common factor. Okay, so let's go ahead and do our two parts, right? Let's factor the front two terms and the back two terms. So for the first two terms, what can we pull out? We can pull out x squared, and we're going to be left with x minus 2. In the back, we can pull out a minus 9. So negative 9 times x minus 2. All right, so we have x squared groups of x minus 2 minus 9 groups of x minus 2. So that means we have x squared minus 9 groups of x minus 2. All right, is this what you have? And if you did, good job so far, but wait, there's still something else we can do. Because take a look at this. We have this factor here, x squared minus 9. That, hopefully you recognize, could be factored one more time using the difference of squares. X squared minus 9 is the same thing as x minus 3 times x plus 3. So the full answer would be x minus 3 times x plus 3 times x minus 2. There's your answer.